So today we're going to learn how to make a binary code necklace and how to wear a piece of jewelry that's a really smart and geeky way to show off your initials using binary code. So the question is why binary? Okay, so a computer is very different from you. You have 10 fingers. A computer is made up of switches. It stores data in a lot of ways that can either be on or off. So if it's an electrical current, it stores it in a switch. And that switch is either on or off. If it's magnetic, it'll change the polarity of the magnet and it'll either have it facing north or facing south. Still two options. If it's something where it's using light to store it, it will make it so that something will either reflect or it'll absorb the light. So either reflecting the light or absorbing the light, like your compact disc does that. When it's on, it reflects the light. When it's off, it absorbs the light. So in all of these ways, the computer is storing things in ways that are binary, either on or off, light or dark, storing or reflecting or absorbing, north or south. These are all the methods that computers use to store things. So one switch in a computer we call a bit, and it's either labeled as on or off. Sometimes we call that 0 and 1. And if you look, the on-off symbol on your computer is actually a combination of those two numbers. It's a 0 with a 1 in the middle. So that's the switch that you switch from off, 0, to on, 1. Bet you didn't know that. So there you go. The computer byte is a collection of 8 of those switches. Now, we're going to see that originally this probably could have been done with 7, but later on we developed a modality for 8. The original idea of 7 was that the 8th one would have been the positive or the negative, but we later on used that 8th one for something other than the positive or negative sign. But we store things in a computer usually in groups of 8 switches, zeros or ones. So this is where we're going to get a string of zeros and ones, and we're going to use that to represent ultimately the initials of your first and last name. So the way that we turn letters into numbers and numbers ultimately into these binary numbers is a thing called ASCII. And ASCII is short for the American Standard Code for Information Exchange. Now, it's particularly American because it uses our alphabet. And if we go over to China or we go to Russia, their alphabets are completely different. So this was developed for the American alphabet. And it took up 128 of our original characters, including our letters and our numbers, capital and lowercase. So we have 8 switches, so 256 positions. The original ASCII system only used 7 of those switches, which is 128. So in our representation, the first switch will always be in the off or 0 or dark position. So the first switch is not going to be used. So 2 times 2 times 2 times 2 times 2 times 2, I don't know, there's 7 of them there. Gets me 128. If you use 8 switches, you get 256 possible positions. ASCII later got extended and used all 8 of the switches, but in our original representation, it only used 7 of them. So our first switch is always going to be off or dark. All right, so this is a big chart that links all of the characters and things that you would typically do with a keyboard to the numbers from 0 to 127. Note it starts at 0, not 1. So that's what gets us to 128. Now, the ones that we're going to concentrate on today are actually the numbers from 65 through 90. Because all of your initials are going to be capital letters, and the capital letters in the ASCII table are represented with the numbers 65 through 90. Now, my name starts with a J, first name, and starts with a B, last name. So the first thing I want to do is work with the J. So the J on that table is number 74 to me, because I have 10 fingers. Okay, but to a computer, which has like 2 fingers on and off, it is 01001010. So in I base 10 system, 74 converts to 7 times 10 to the first, 70, 4 times 10 to the 0, 74, or 4. 70 plus 4 is 74. That's how it works on our base 10 system. And I get this because I have 10 fingers. A computer, though, has switches that only have 2 positions, on or off. So we're going to use 8 of those switches. The first one is going to be 2 to the 7th. The last one is going to be 2 to the 0. So remember, it's 0 through 7, which gets me 8 switches. Now remember, we're always going to have that first switch in the off position. So that's 0 times 2 to the 7th. Now, if I take the next switch, I'm going to turn that one on. So it's going to be 1 times 2 to the 6th. The next one is off, 0 times 2 to the 5th. The next one's off, 0 times 2 to the 4th. The next one's on, 1 times 2 to the 3rd. The next one's off, 0 times 2 squared. The next one is on, 1 times 2 to the 1st. And then the last one is off, 0 times 2 to the 0. So if I do those exponents, 2 to the 7th is 128, so this is 0 times 128, plus 1 times 64, plus 0 times 32, plus 0 times 16, plus 1 times 8, plus 0 times 4, plus 1 times 2, plus 0 times 1, which is 64, plus 8, plus 2, which happens to add up to, lo and behold, 74. So the way I write 74 is to write a 7 and a 4. The way the computer is going to write 7, 4 is off, on, off, on, off. Okay, so it's like counting with 2 fingers here. All right, so that's pretty complicated. We're not going to make you do all that mathing today. We actually reduced the alphabet to a nice, neat little chart here. So if you can look at the J in the chart, you'll see that it's exactly like we said. It is off, black, on, white, off, black, black, on, white, off, black, on, white, off, black. So that's the J. Okay, I'm going to have to do this also for the B. But this is going to be the bead patterns that I use to spell out my initials on the necklace. So let's make a necklace. Okay, so the first thing you're going to need to do is you're going to have to pick a strand. And you can pick a color, whatever you want to use. And because this is a Pinteresty kind of thing, there's always the little hitch, right? So if I take a look at the strand and I look at the beads almost perfectly go on the strand except for the last little loop right before the bead goes on the strand. So what we need to do is we need to take a pair of needle nose pliers and you need to mash that last little loop just a little bit and all the beads will go neatly on the strand. So this is your Pinterest moment. Break out the tools. Let's get a little messy here, right? So it'll go through all the little links and then that last one you got to mash down a little bit and it'll go right over top that link. So the next thing we need in making our necklace is to look up your initials on the chart. Now, my initials are JB. Other people, one of my son's initials are CB. He's going to pick up 2 different initials, right? So my initials are JB, and I'm going to pick up the beads that go with the J. Dark, light, dark, dark, light, dark, and B, dark, light, dark, 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 light, dark. Okay, so it's going to give me a whole bunch of black and white beads. I also want to have one bead that's clear so that it goes in between the 2 letters, right? See where the end of one letter is and the beginning of the next one is. All right, so the next move is to obviously thread your beads. Put them in the order from beginning to end of the 2 initials. Make sure that you put that clear one in the middle so that it's between the 2 letters. Once you've thread all those beads, you can take that, put it around your neck, clasp it in the back, or have a friend help you, share it with your friends, and feel smart. When somebody says, hey, what's that necklace? You go, it's my initials. And they go, huh? This is my initials. And you say, look, if you were smart as a computer, you'd be able to read that clear as day. These are my initials spelled out on my necklace. All right, so this is how to make a binary necklace.